For this question, we're given a series of equations and we need to find x, y and z. So I'm going to start by putting that into matrix form, where I'm going to use the coefficient of each of the x, y and z. So coefficient of x is 1, 1 for the y and negative 1 for the z, negative 2 for x, negative 1 and 1, 1, 2 and 2. So they're all my coefficients. And if I was to multiply that by x, y, z, I get my answers 9, negative 11, 0. So if you recall matrix multiplication, that would give me 1x plus y, showing that, take away z, and that gives 9. Then I could do the same thing with the second row, negative 2x minus y plus z would give me the negative 11, and so on. So I'm going to call this matrix A, and call that one matrix X, and this one matrix B. So first of all, what I'm going to do is work out the determinant of A. So that can be written as A or determinant of A. So negative 1, 1, 2 and 2, so they're the numbers that are in different rows and columns to that 1. Remember to change the sign so it goes positive, negative, positive. Then we'll have negative 2, 1, 1, 2, plus negative 1, so this is the third column. So in each of these smaller matrices, I'm using the numbers and columns that aren't in the one that's on the outside here. So following my rule for determinant, would have negative 1 times 2 is negative 2. Take away the 2, would have negative 4, plus 5 plus 3 equals 4. In each case, I just worked out the determinants. Now, the next step we're going to do is work out the cofactor matrix. So I start by showing my smaller ones. So we'd have plus, minus, and plus. Then we alternate, so that would be a negative, positive, negative, and then we'd have a positive again, negative, and where I'm putting my line, sorry. Should be there. Okay, so for the first one, that'll be the same as my determinant above, where I had negative 1, 2. Then for the second row, first of all, looking at the negative 2 here. So the numbers that go inside the lines will be the 1 and the negative 1, and the 2 and the 2 that are in different rows and columns to it. Then negative 1 is in the middle spot, so I'd use the outside corners because they're in different rows and columns. And for the third one here, we'd have this one here, and use the 1 and the 1, the 1 and the 2 that are in different rows and columns to it. And then follow the same procedure for the bottom row. And now to work that out, so working out the determinant of each one of those individual ones. So for the first one, we've got negative 1 times 2 would give me negative 2. Take away the 2 times 1, so that gives me negative 4. Then I keep following that same process. So that's my cofactor matrix. Then we need to work out the adjoint of A, which will also be the same as the transpose of C. So with the transpose, the numbers that are on the top row become the first column. So negative 4, 5 and negative 2 to go downwards now. Then the negative 4 and 0 that were on the first column become the first row. And I usually do my diagonal, that doesn't change, and then I swap the last two numbers over. Now to work out the inverse, the inverse is equal to the adjoint A divided by the determinant of A. So my determinant was 1/4. Oh, so it was 4, so we get 1/4. And when I break that out, we end up getting 1/4 of -4 gives us -1, -1, 0. 5/4 is 1.25. Oh, sorry, I made a mistake there. That was meant to be a 3. So move that 0 across. And that gives me my inverse. Now, I guess the reason I've done all of that is that we've got the matrix A multiplied by matrix X, and that's giving us B. We're trying to find out what the value of X is. So I basically need to get rid of the A that's multiplying it. So if I multiply by the inverse of A multiplied by A will just give us the identity matrix. So that's like the equivalent of 1. So if I'm doing that to the left-hand side, I have to do the same thing to the right-hand side. So that will give me that X is equal to the inverse of A multiplied by B. So now we can work that out. So starting with my inverse, which we've just worked out. And matrix B was the 9, -11, 0. So now when I do my matrix multiplication, we've got -9 plus 11 plus 0, so that will give me 2. Then we do the same thing for each of the rows, and we end up with 3 and -4. So what that tells me is that X is equal to 2, Y is equal to 3, and Z is equal to -4. And then for your communication justification, you should always do a bit of a check. So I'm going to use the third equation. We've got that X plus 2Y plus 2Z. So I'm going to plug my values in. So X is equal to 2. Then we've got 2 times 3 and 2 times -4. So when we work that out, 2 plus 6 is 8. Take away 8 equals 0, and that was the correct value.